name's Robert Dickerson. I've been at TRAC for a little over 12 years now. I'm in my 13th year here at TRAC. I have a Bachelor's of Science in Mechanical Engineering from New Mexico State University. I have a Master's in Business Administration from UTEP. I also have a Master's of Science in Industrial Engineering from TRAC, which I earned while I was here working at TRAC shortly after I started working here. And as just like Ryan Foulon mentioned in the previous brief, if you watched that one, I also have a data science certificate from the Naval Postgraduate School out in Monterey, California. Again, which I also earned while I was here at TRAC. Just recently finished that program about a year ago. So for those of you that are tuning in, thank you. We're going to be talking a little bit about pivot tables. If you're not familiar with them, great, glad you're here listening to what we've got going on. If you are familiar, this could just be a refresher, maybe something you haven't done in a while, maybe some new techniques or tricks that I might be able to show you. There's going to be kind of two parts to this presentation, kind of go through some slides, and then I'm going to actually switch over to Microsoft Excel and kind of go through live a couple of questions and answers, kind of how to manipulate the data, the pivot table, so that you can find different things that you're looking at. So, and since this session is recorded, you can always come back and look at how to recreate some of the stuff that we do today on your own time, to kind of play around with it and then explore and play around and see what you're doing on yourself. So, so for today, again, providing an overview of pivot table analysis and some practical examples. I've got some questions at the end we'll kind of ask ourselves, and then we'll kind of manipulate the data. We're going to go through a little introduction about what pivot tables are, some terms of reference, some advantages and disadvantages, so things that I've kind of picked up over the years, and then some stuff I kind of read about on the internet and stuff when I was putting this briefing together. How to create a pivot table, so it's a 5-step method, really simple for you to do on your own end. And then again, those practical examples about what we're doing. All right, so introduction here, pivot table. It's a summarized table of statistics of more extensive tables. So you're looking at taking a very large data set. Usually in this example that we're going to be doing today, we're dealing with a data set that has 500 lines of information. I've dealt with over 1 million lines of data, numerous columns of data and different information that we're looking at, especially when we're looking at the output from some of our combat models that we deal with here at TRAC. And again, pivot tables is just analysis. It's just a technique, the data processing, and we're just rearranging the data, looking for things in the data that identify trends, identify what's going on, how can we see what's going on with, you know, if we're looking for combat models as far as, like, you know, how are we surviving, how are we killing the enemy, how fast are we moving, things along those lines. Again, pivot tables can be used across many different platforms. However, Microsoft Excel is probably the most common, just because everybody has Microsoft Excel if you're working with a PC. Even applications on Apple and other platforms, you're using some type of pivot table analysis in there. The data can be summarized in the pivot tables and be used to generate charts for visualization. A lot of times people are visual learners. So you're looking at a table of information. Okay, what does a picture look like? What can I tell from the picture? What can I ascertain or infer about what's going on? And then one thing to remember is when you're dealing with pivot tables is we're not actually changing the original data. We're not transforming it. We're not going to be deleting information. I'll show you a trick, something I might do where you might add something to your data set to make it a little bit more user-friendly. However, when you're doing analysis with other programs, you may actually start manipulating data inadvertently and losing something that you didn't mean to. So with pivot tables, that tends not to happen, especially when you follow my 5-step method on how to do it. You're really not going to be messing with your data. So, all right. So just some terms of reference. On the right-hand side of the slide, you'll see this is the pivot table fields, and this is from Excel. And you'll see that at the top you have the what they call the field, which are the building blocks for how your data is set up. Each one of each one of the things on the top that you see with the little square next to it is a header column. It's one of the names that's on top of the data. And in the table, you'll be able to see that in a second. In the lower half of that image on the right, you're going to see 4 quadrants. The top left quadrant is the filter. Now, this is a global filter. So if I wanted to globally filter all of my data, in this case, it says G. And for this exercise, I'm going to be using some data that was collected out of an NBA season. So G in this case is games, the number of games that were played by a particular player. So I can filter that data on how many, like I want to have more, all the players that have played in more than 10 games or less than 3 games, or there's 82 games in the season. So I want to know everybody that played in at least 70 games of the season. And you can start manipulating that, looking at that data as you need to. To the right of that quadrant, you see columns. And columns is just it's the ability to filter by one or more columns of the data. So we could put, in this example, you don't see anything in there, but we could put something in there like, what is the field goal percentage, or what was the number of 2-pointers attempted, or what else is on that file? Number of field goals attempted, so free throws that they were taking, things like that. The rows, you can see down in the lower left-hand quadrant of the image, it says age. So in here, I wanted to break up the data by how old the players are. What was their age during that NBA season? Again, another way just to compare creating that data table for you to further analyze out of all of the data that you have. And I'll show you a picture of the data here in a couple of, when we switch over to Excel. And then the last section, that lower right-hand quadrant, the values. In this case, I'm looking at what was the average number of 3-pointers that was taken. And in the values, there's a couple of different sets that you could do. You can average it, you can sum it, you can count it, and we'll see that here in the practical example. But that's where you're going to get the data to fill the table. So Excel starts doing some math in the background and starts giving you that information. All right. So now that we have the terms down, let's talk a little bit about the advantages and disadvantages. Of course, I'll start with the good things. So the first one here is pivot tables allow the user to see how the data works. So you can quickly change columns to rows. You can quickly change in and out the values, and you can quickly see how fast data can change. You're really limited on just the memory of your computer, really. And the size of the data set. A lot of times, if you're coding in R or some other programming language, Java or Python, and you want to make a change that's quick, usually going back into the code, you're making a change in the code, and then you're rerunning that data through the algorithms and within the program to get a new picture. With Excel, you can do it very quickly. You can do it a lot faster. And you can just really see how that works. The pivot tables can be used with exports out of SQL. So if you have a very, very large SQL database, you can export data out of that database, and then you can upload that back into Excel, because once you download it out of the SQL server, SQL database, it's probably comma delineated. You can drag that back into Excel. It becomes an Excel table. Then you can create a pivot table on it, and you can start analyzing that data on the fly. Data is easier to segment, especially within large data sets. You tend not to have to filter out or create a smaller data set to be able to use pivot tables. The next advantage, visualization charts. They're connected to the pivot table, so you can change the pivot table and the chart will update automatically. So you can quickly get that visual look of what's going on in the data and see how making a change could show something else, could give you some other indication of what's going on, and how you can maybe look for other trends, like, hey, that shows a pretty good image. Let me save that image. Let me try to dig deeper into this and figure out what it is that's going on. And the last advantage that I came up with was that, pivot table software, i.e. within Excel, it's readily accessible, thus providing this powerful tool to anybody, whether it's your computer you're using at school, computer that we're using at work, or if you ever deploy downrange into a forward operating area where civilians could be working, in a forward area like in Iraq or Afghanistan, supporting troops on the ground. Excel is going to be available to you. You'll be able to analyze data using that software. So some of the, what goes with the good is you got some of the bad. So what are the disadvantages? Calculations beyond what's built into the pivot table. So like I said, the ability to sum, to count, to average is built in. Anything beyond that, you kind of have to do offline on yourself. So if you're looking for standard deviation, you're looking for, you want to add multiple columns together within the pivot table, that can get quite cumbersome, and you're doing it offline. The pivot table doesn't want to automatically do that. And if you build in a function, once you change the pivot table, reference cells no longer are there anymore, and you break that chain in the calculations in the formula, and you're having to go through having to do that all over again. So it's kind of one disadvantage. Whereas if you programmed it in R and you ran your data through and there was a line to do that calculation automatically, you're going to get that result every time that we run that data set. So there's no automatic updates to your pivot tables when you change your data set. And I'll go through that and show you an example of that. So if you change the original data set, you got to tell Excel that you changed it. Otherwise, it's never going to include that new data. Thus, you're essentially creating a new pivot table based off of the new data. So, third disadvantage: pivot tables are memory hungry. So when you have an older computer with a very large data set, and it starts to maneuver and it starts to change the data very quickly because you're swapping columns and rows in and out, you're changing the values, you're doing all that kind of manipulating very quickly. Depending on your computer's capabilities, it could get a little slow, could lag behind in what's going on, and then you just kind of get frustrated because now your computer's fast enough and it says it's not responding. And you're like, oh, I'm just going to turn off my computer and start over. So that's kind of one disadvantage that's going on. The last thing, and I guess it's kind of a mix, is advantages and disadvantages. Is there's no one way to do it. So practice makes perfect, and a lot of times you're going to be working through, and you just trial and error. You put it together, you're like, well, that doesn't show me anything that I was expecting to see, so you start over. You change it around, you look at it a different way, and I actually have an example of how that could work, and we'll do that. So, and kind of the big takeaway from these advantages is just want to remember that pivot table analysis, they're available on all your computers, and I actually encourage you, you're still in school, you still got a couple more years, maybe you can figure out, like in a future project that you can do you're going to get some large data sets. Do this analysis, practice it, because we use it at TRAC, and you can use it in lots of other applications as well. But I can tell you, for probably the first 2, maybe 3 years that I was at TRAC, this was like the way to go. We were doing this every which way there was, spending all day, every day, analyzing data through pivot tables, creating charts, looking for those trends, looking for those nuggets of information that we would then put together with the story of how what's going on within the scenario and what's going on and how these different technologies are supporting the soldiers in the studies, and then the senior analysts on the team were then putting together those briefings that then were going up to the senior leaders, and multi-million, billion-dollar decisions are being made off of what we did on the pivot tables, on our computers working at TRAC. So any experience that you can have practicing and working on this, you just add it to your resume. Great tool in giving you the opportunity to work with that now. So how do we create a pivot table? Really easy. So here you've got 5 steps. You're going to go to the Insert tab on Excel, and I encourage you, if you have Excel open, go take a look. Go to the Insert tab on the top. On the left-hand side, it's going to say Pivot Tables. click that, you're going to get a pop-up window, and it's going to say select the range of your data. In this case, it's all of the data that you have. So it's telling Excel where to go find all of my data. Number 3 gives you a couple of options, either in a new worksheet or an existing worksheet. My best practice to tell you would be to click new worksheet. What it's going to do is going to create you a new worksheet down on the bottom, a tab on the bottom that you can then play with, you can work on. The other one, it's going to put it over the top of your data, and it just gets confusing to look at. So my best practice would be to create a new worksheet, put it in a new worksheet, and then you're going to click OK, and then you'll see down at the bottom that sheet 1 is selected off of the data. Okay, so 5 steps, really easy. I encourage you to practice that on your own. All right, so here's a practical example, and this is a table that I put together, and based off of the picture that we saw before, was I have on this, in my data set, which is 500 rows, I've now taken all the information and I've summed it down into this table that you see here. And on the top, I've got a global filter for games. In the rows label, I've put the team. So I've put the team name on the rows. On the column, I've put the ages of the players. And then in the values section, I've actually put the average 3-pointers made. So I put the 3-pointers made column in. I changed the summation to an average, and then of course I formatted it to 2 digits because some of them get really long, 7, 8 digits because it's a floating decimal. So I got it so it could all fit on one page. So you could quickly look on here, and you could see that. Let's take the first one, Atlanta. So the Atlanta Hawks have nobody in this particular season of data that we're looking at that was the ages of 19 or 20 that made any 3-pointers. You could say everybody that's on their team is usually between 31 and 21, and they've got a 43-year-old on their team, probably Vince Carter. If you're familiar with NBA, he's probably on their team because he's quite old for an NBA player. And then you could see on here what the 5 team down in the bottom where it says grand total. That's the average number by all 19-year-olds in the league, or the 22-year-olds. And then you could see that all the way in the right-hand side, the bottom right-hand corner, 43.18. That's the average number of 3-pointers made across the entire league in that year that we're looking at for all ages and all teams. So on average, you could say that any particular team is making about 43 3-pointers in a season. Some teams are probably a lot higher than that, but especially with Steph Curry shooting on your team. So let's take this data and let's chart it, because visually you can see what's going on. All right. So the top chart, the top left-hand chart, you see the that's what that data looks like. That chart that we've got there, all the colors, everything that's showing up, that's what that chart shows. That chart's really hard to look at. There's a lot of different colors going on. There's a lot of ups and downs, a lot of trying to understand what's going on. The only thing that I could kind of take away from that is I could quickly see which teams are making the most average 3-pointers, and that I'm just looking for the high points. So looks like Dallas, Milwaukee, Portland, maybe that's probably Toronto. So those 4 are probably the top 4 shooting 3-point, or the average 3-pointers made for the whole season. But like trying to look at that chart by age, it's really hard. The other table gave us a lot of really great information, but looking at it on a chart, probably not so much. So what we do is we swap the data out, and in the lower right-hand corner, what I did was I went and I took the teams out. I took out the number, the by team is then removed, and I changed from the age from the column down to the row, and now I've been able to quickly see, where is everybody shooting by age. If you're familiar with the NBA, you know that the average player hits their prime between 25 and 31. So if you're looking at the lower right-hand chart, you can see from age 25 to about 31, you've got an upward trend in the data. So kind of coincides with when the players are hitting their prime. So when they're playing at their best. In the lower right, you've got 19 to 24-year-olds. Those are those players that come in. They're on their rookie contracts. Most rookie contracts are between 2 and 4 years. Most NBA players they have to go at least 1 year to college, which is why they can't start till they're 19. Most come out a little later, maybe sophomore, junior, your senior year. So you got a little older age. That's where your 20, 21, 22-year-olds might come into the league. And then you've got those outliers, those players that are way out there in age. 43-year-olds, probably Vince Carter still out there playing. The 38-year-olds, we can dive down to see who that is, but my guess is LeBron James. Been out there playing, been in the league a long time, so he's probably at that 38-year-old range for this data set. We'll be able to look to see who's in 35, but from 31 down to 36, you see that downward trend. So the players have already peaked in their age, and now they're coming down on the backside of their career. Other than those, peak players that are out there playing past their prime. So kind of a different story. Same data set. All I did was I just changed how I'm looking at it. Now this is a chart that may be more useful, tells a little bit more of a story, quickly ties to information that we may already know from our front-end analysis that we did in the study that, hey, prime players are between 25 and 31. Now we've got some data, some charts, some visualization to coincide with that piece of information that we already know. So, okay, so practical examples. I'm going to leave these up for just a quick second, and then I'm going to take them down because I'm going to switch over to Excel. So a couple of things that we're going to look at, and time permitting, we've got about 8 more minutes. So average three-pointers made by age when the players play at least 3 games. At least 11 games. So they have to have at least played in 11 games in the season. So those guys that come in on a 10-day contract and only play 10 days, and then their contract's over, we don't care about those guys. They're there for a band-aid. They're not helping their team very much, other than get through a small spell in the season. What's the average age by players by position? How many players are there by position for each team? And then what's the average number of games started by age by team? So we'll stop sharing, and I'll switch over to Excel, and we'll start playing with that one. Okay. Now we're going to switch over to Excel. All right, you should be able to see my Excel sheet up here right now. Okay, so here's the data set that I've been talking about. And you can see if I scroll down, so this is all players, and this is in position, their age, the team, and then there's a whole lot of different information across the top. That's the column headers. And like I said before, this table here has 500 rows of data. 407 players are on this list. Okay. So to create the pivot table, we go to Insert. Oops, hold on. This could just the other way. Okay. Insert pivot table. Okay. Come on. Pivot table. That's my data. A new sheet. I click OK, and then it's going to pop up on the bottom. So we can see, it's going to be up here, and my Excel is very slow. Hold on. See, told you, memory doesn't want me to stream video and do pivot table analysis at the same time. Hold on. Okay, we see it now. Pivot table, data range, data. In Excel. File now. At its best. Come on. 1 second. Wait this again. Okay, I think we're up now. Hope you guys can see. All right, so I have my pivot table, new sheet, and my insert. Okay, so now I've got it on the right-hand side. We're going to recreate, and our question was average three-pointers made with at least 10 games. So we're going to pull the games into the global filter, pull them down here. We're going to want the three-pointers made. And I'm going to change that to an average. And then I want to know by age. So I'm going to pull in the age here. Right, so this is the average three-pointers by age. And I'm going to filter the fields that I only have 2 decimal places. And I'm moving faster than Excel can. There's 2 places. And then I want to know here, I'm going to take out all the games that are less than. I've got to play at least 11. So I'm going to filter out everybody that's less than. So 11 or more games. So now now I just manipulated the data. So now it's the average three-pointers by age for all the players. And you can see if they're playing at least 11 games or more, they're shooting on an average. They're making 34.67 for all the 19-year-olds in the league. So, so we can do that, and then I can insert a chart if I wanted to chart it. So this is the chart that we were looking at before. Slightly different than the one that's in the presentation because I've taken out all the games that are not that are less than 10. However, I can show you that if I come in here and I say give them to me all, then you'll see how the chart will update itself. It changes slightly because there's now more data to be included in the chart. So, and let me put one more in. So I'm going to put in here. The charts are updating as I'm changing the data. However, it's a little difficult to read. But you can see here, if I'm looking at average age of players in the by position, now I can see what their average ages are. So centers, and again, you'll see there is some data issues because there's centers here, but then there's also center power forward here and a power forward center. So there's players that are filling both the 4 and the 5 role, and you would have to figure out how to add that, how to re-average those information. Again, something that's done offline, not something that's done within Excel. Kind of that disadvantage because of how it's labeled. So you can see how this data now might show you that 11. So the power forwards centers kind of have a higher average versus just the shooting guards that are labeled as only shooting guards in the league. So I know there's not much time left. If anybody has any questions, I encourage you email the Dropbox, and I will share this data set with anybody that's interested to at least have the same data that I've got, and then they can kind of go back and recreate, maybe the chart that's in the slides, the data table, and you guys can play with it that way. So thank you all for your time. I think we're just about out here, and I look forward to hopefully seeing some of you in TRAC's hallways here soon.
Thank you so much, Robert. That was so interesting, and I just loved the data set that you used to do the demonstration. That was awesome. If anybody has a question, our next presenter is giving Robert 5 minutes of his scheduled time. So please, if you have any questions, we can go to 9:50 if you have a question for Robert. Go ahead. Okay, John, why don't you bring up your slide deck and we'll move into your presentation.
Hold on one second, Steph. Walter does have a question for Robert.
Oh, thank you.
Walter, go ahead.
Sorry about that. I just want to double check the email that we can contact you at for the data sets. Is that the just the recruitment email?
Yes.
Okay.
It's where you sent your registration form. Yep.
Perfect. Thank you.
You bet. Can we get a comms check with John Hauser?
Thanks again, Robert.